Let's say you have an expression like x raised to the power of x. Here we can't use the power rule because x is not a constant, so what can we do? We can use logarithmic differentiation. I'll show you. So x to the power of x, let's set this equal to y. Let's take the logarithm of both sides. The base you use actually doesn't matter, but typically using base e will be the easiest. So ln of x to the x is equal to ln y. On the left-hand side, since we have an exponent inside the logarithm, we can move that to the front. So we're going to have x times ln x is equal to ln y. And now we're going to differentiate both sides. And a rule of thumb, if you have ln of, let's say, f, the derivative of this is going to be equal to f prime over f. Okay, so the right-hand side here, that's just going to be y prime over y because of that rule. And now for x times ln x, that's just a product rule, so x times the derivative of ln x is x times 1 over x. And then we add the other part, which is going to be 1 times ln x. Okay, our left-hand side simplifies into 1 plus ln x equal to y prime over y. Okay, we can multiply both sides by y to get y prime by itself. We're going to have 1 plus ln x times y equal to y prime. And remember that y is equal to x to the power of x, so we can just substitute here. And that's our derivative. Okay, now for a more complicated example. So we have sine of x raised to the power of x. Okay, we're going to set this equal to y. Then we're going to take the logarithm of both sides. Bringing this exponent to the front. Okay, now that we have these equations ready, it's time to differentiate. Okay, the right-hand side, again, that's just going to be y prime over y. Okay, and for our left-hand side, this is a product rule. So we're going to have x times the derivative of ln sin x prime plus 1, because the derivative of x is just 1 times ln sin x, which is going to be ln sin x. Okay, to find the derivative of ln sin of x, we could either use the chain rule or the ln rule. The derivative of ln, remember, is ln, derivative of ln f is going to be equal to f prime over f. So here we're going to do sine prime over sine. Sine prime over sine for this derivative. And sine prime is cosine. So this is cosine over sine, which is cotangent. So this derivative is just cotangent. So we have x times cotangent plus ln sine of x is the derivative of the left-hand side. And this is equal to y prime over y Okay, multiplying both sides by y. Prime. And finally, we can substitute this y term. And this is our final derivative.